Okay, so we're Svetlana. Thank you. So we're Svetlana, Carla, and Paulo, and we used time series analysis to predict the US economy. So the main idea is that if you choose the right econometric model, you can input past values of key macroeconomic variables to predict those key macroeconomic variables in the future. Coding itself wasn't a problem really, it's a rather straightforward R package. The difficulties lied in choosing the right variables, finding the data on those right variables, transforming them appropriately so as to have linear relations between them, and choosing the right model specification, specifically the amount of lags that you needed to use. The method we used is called vector autoregression, VAR, which is basically a system of linear regressions that used, in our case we used 7 variables, so it's a system of 7 equations, each one with 14 different x's. It includes 2 lags of each one of our variables in each one of the equations. So what we did, choosing the variables, finding data on those variables, then transforming them, first difference or log, selecting the appropriate specification, the amount of lags, and then using the data between 1980 to 2015 to predict the values for 2016, 17, and 18.
So shortly about the data, we used the data from official source, Federal Reserve. There we used data from the time span 1980s to 2018, and then split the data to the training data and prediction data. Also, we use quarter data and seasonally adjusted. There are many varieties of variables that one could use for the forecasting of economy. In traditional settings, the economists and researchers are using mostly the real GDP to judge the economic growth. In our model, we use inflation, real GDP, wages, consumption, investment, interest rate, and unemployment. And also we use, because of some variables, they have many proxies. So we try to find the most efficient proxies for our values. For example, for inflation, it's implicit price deflator index. And now my colleague Carla will continue.
Okay, so I'm going to talk a little bit about the results. So we did the forecast. So just to explain a little bit the graphs first, we have in the x-axis our time series, and this is the graph for each of the variables that we analyzed. And the yellow part of the graph is actually our forecast from 2016 to 2018. So in general terms, we have a stable increase of the US economy for GDP, consumption, and employment. However, for the unemployment, we have some variation there, so we have some fluctuations. So we need to understand how accurate is our model, so I'm going to try to explain a little bit of it. So the first predictions that we do, it's always based on the real data, but the next ones are always based on the previous prediction. So from the third quarter, I'm sorry, I can't point it. We are going to start having an increase in our confidence intervals, so it's going to be larger. So we can see that the confidence interval starting 0.4% and then starting to increase to the last lags that we predict for 2%. Okay? But how is this related with the accuracy of the modeling? So I'm going to show an example that makes things simpler, hopefully. So what we are expecting is that in the beginning our prediction is going to be close to the real numbers, but in the end we are going to start having more error, and then it's not going to be so close to the real values. So I'm going to tell about the unemployment as an example. So the first prediction we did for the unemployment is exactly the same value as we get in the real data. However, when we go to the end of our prediction, 2018, we can see that our prediction for unemployment is actually higher than the value. So we had a prediction of 4.6%, and the real data is 3.9%. However, this is a very similar value, so we can say that everything is fine, and we have exactly the same pattern for all the other variables. So in general, we can say that our model more or less can predict the US economy in short term. Thank you.